Good morning. Our today's topic is major techniques of polymer processing. This is a part of polymer industry, and polymer is considered as the third generation petrochemical product. So, in downstream of petrochemical industry, polymer is their main raw material, which is being processed for producing different polymeric articles and polymeric product. So there must have some definite techniques which are being adopted by those industry. And today's topic is mainly to discuss about the major techniques which are being followed and which are being practiced by the polymer processing units. So the polymer, virgin polymer, which is obtained from the petrochemical industry, but that polymer is being used by different customers, by different users, and for giving the final shape of polymeric product, it is required to meet the criteria where it is to be finally used. So the virgin polymer, before to produce the final product, polymeric product, it is required to incorporate some specific ingredients into it, and that particular process is called the polymer compounding process. So generally, depending on the purpose of final use, we have to choose compounding ingredients, and accordingly the selective compounding ingredients are being used by different polymer processor unit. So polymer compounding is a process, is a mandatory process before to give the final shape of product. So compounding ingredients, these are generally categorized in different categories like fillers, like plasticizers, lubricants, flame retardants, impact modifiers, coupling agents, anti-static agents, antioxidants, photostabilizers, heat stabilizers, antiozonants, colorants, blowing agents, compatibilizers, curing agents. These are the broad category where we have to select our desired compounding ingredients based on the final use of the polymeric product. Fillers are mainly the main two purposes are there. One is for reducing the cost. Another one filler which are popularly used to increase the property of the final product. So the effect of mineral fillers of plastic, generally the fillers can be used as a reinforcing filler and the inert filler. The main role of inert filler is to reduce the cost. But the reinforcing fillers, which are mainly used for increase the property, to increase the property like tensile strength, like stiffness, like weather resistance, abrasion resistance, surface hardness, thermal conductivity. Those properties of the final polymeric product is being increased and is being achieved by using these kind of reinforcing fillers. And sometimes they reduces the elongation at break, the creep, gloss, flammability, coefficient of thermal expansion, shrinkage, cost. The second compound is the plasticizer. Plasticizer is actually used for plasticizing the material. Plasticizing means to introduce its softness, to introduce the rubber kind of properties. plasticizers are generally being used. This is the main purpose of using plasticizers. Some other effects are also there when the plasticizer is used along with the other ingredients. Some other effects that can be induced. So you can understand that plasticized PVC, polyvinyl chloride. Generally, polyvinyl chloride plastic is hard, but during processing, if the sufficient amount of plasticizers are used or incorporated with it, so the flexibility is induced. So the plasticized PVC can be used for making the waterproof clothing items. Plasticized PVC is soft and flexible, but unplasticized PVC is generally used for making the door, windows frame. Means this is sufficiently hard without plasticizers. So generally the phthalate esters, these are popularly used in PVC as plasticizers. Lubricants. Lubricants, the main function to reduce shear heat, to reduce viscosity, it gives glossy surface finish and aids in the dispersion of pigments and fillers. So it also helps to distribute the other ingredients also. So generally lubricants are used to decrease the friction. So generally classification of lubricants can be made. One is external lubricants, which is provided lubrication between polymer and metal surface, like paraffins, like waxes. These are the externally applied, and that's why these are external lubricants. And internal lubricants, which are semi-soluble plasticizers. So reduce actually frictional forces between polymer molecular chains, thus reducing melt viscosity. So melt viscosity is one of the primary parameter for any polymeric product. So the melt viscosity is further reduced by incorporating the lubricants like fatty alcohols, esters. So it works internally actually. They are reducing the frictional forces between polymeric molecules. Third is flame retardants. So in order to understand the mechanism of flame retardant, we must give brief description of fire cycle, because you know what is fire cycle. Cycle is having different phases. One is condensed phase, gas phase. So these two major phases are identified in the fire cycle. So in the condensed phase, mainly the pyrolysis, that is the degradation of polymeric long chain molecules, occurs, and due to that the emission of flammable gases and formation of inert carbonized material, and ultimately this is called char. And the gas phase of the fire cycle, this is the flammable gas are mixed with oxygen from the air, and proper mix of oxygen and fuel is released in the combustion zone where exothermic chemical reaction takes place involving high energy free radicals formation. So this is the fire cycle. You can understand one is the combustion zone. So the first is the ignition source. This is ignition source. Then the local degradation process starts, and after that char is formed at the end. The flammable gases are coming out. After that, it mix with the oxygen, air and oxygen, then ultimately goes to the combustion zone. So the exothermal radical chain reactions between fuel oxygen and high energy free radicals flame formation. So that Once the free radical is generated, it is further propagated and enter into next phase. So ultimately the energy is produced. So this is ultimately, this one is a gas phase, this is meso phase, this portion, and this one is the condensate. The bottom is 2, 3, 4. These three phases belongs to the condensed phase, and other phases mostly they are belonging to the gas phase. Flame retardants, so another one ingredient which is used to resist the fire accident, that is to reduce is reduced to catch fire. So mechanism, there must have some mechanism of using that flame retardants. So if we look into the mechanism how it works, one is gas phase inhibition. From the fire cycle we have seen the gas phase inhibition, then condensed phase, char formation, then physical phase. Gas phase inhibition, we have seen that the flame retardant stop the radical mechanism that takes place in gas phase, and ultimately the solid phase of flame retardants are those which cause a layer of carbon char to form on the polymer surface. So by the mechanism of combustion, so the char, carbon char is produced, which is deposited on the surface of the polymeric material, and that carbon char layer is much harder to burn by insulating the plastic from heat and prevent the release of flammable gas from the bulk. That is the main mechanism. Physical action, if we look into the physical action of the flame retardant, then some chemical reactions actually cool the material down, forming a protective layer that prevents the underlying material from igniting. One example can say that when aluminum hydroxide is heated, it dehydrates to form aluminum oxide, Al2O3. So releasing water vapor in the process. So this reaction absorbs a great deal of heat. That's why the system is cooled down further. And one dilution effect also may be there. One is some retardants released to water or carbon dioxide while burning. And this may dilute the radicals in the flame enough so that its reactivity will go down. Coupling agent. Coupling agent is another one important ingredients which are used in polymer processing. That is the use surface treatment in composite to improve the interfacial bond. Sealants type. Sealants type, this is used primarily with glass, but can be used with other fillers that have an OH group on the surface. And another one is titanates or titanates. Titanates which are using the OH filler, used primarily with OH fillers and more thermally stable than sealant. This is the structure. This is the original material, and silicon is there. The silicon is inorganic material, means this is combined with silicon functional groups, that is X, and R is the organic functional group. Impact modifier is another one important material where blending with the impact modifier, the impact strength is further increased. So blending with impact modifier creates a combination of hard and soft phase. Mechanical energy is initially absorbed by the hard plastic phase, and then it is transferred to the enclosed soft plastic phase. So if energy cannot be transferred to soft phase, that cracks forms, a stress concentration is created at crack, and crack propagates and fracture occurs. So obviously, if the crack, if impact modifier is not there, then due to impact, if the surface cracks once developed, so it will be propagated further, and ultimately fracture will be generated. So in presence of impact modifier, the initial impact that is being absorbed by the surface. Anti-static agent, it reduces the friction, because due to friction with the polymeric material, uh, statical electricity will be developed, and that is obvious. So to reduce the friction, uh, that anti-static agents, these are used, silicon oil like material, which is used during compounding. So at the finished product, the friction with the surface, that will be reduced, so that the anti-static or statical electricity generation can be reduced. So how it is used? So organic plastic material, insulating material that build electric charges, so dust attraction and sparking, these are the obvious nature due to generation of statical electricity. So that can be reduced by using anti-static agent. These anti-static agents are generally classified in two categories. One is internal anti-statics, anti-stats, and another one is external anti-stats. Obviously, are mixed with the polymer. Internal means it is internally mixed. So before giving the final shape of product, the virgin polymer will be mixed uniformly with the anti-static agent, that is the internal antistats. And external antistats is after giving the final shape of polymeric object, it is applied on its surface, so that it will be reducing the surface friction. The orientation of the antistatic molecules will be like this is actually the internal antistats, and this one is actually the external antistats. Anti-aging additives means aging means kind of degradation. This is actually the natural degradation. So if any polymeric product is exposed to the environment, you will find that after some days some cracks will be developed and deterioration is completely visible. That is mainly the degradation of the polymeric molecule. So anti-aging additives includes antioxidants, because the degradation of polymer that may be due to oxidation. That degradation may be due to an antioxidants, means uh, oxidation, ozonation means ozone reaction with it, and photodegradation or thermal degradation. These are the normal processes of aging of polymeric product. So if it is possible to prevent the aging of polymer by using a suitable antioxidants, by using a suitable antioxidants, by using a suitable photostabilizers, using a suitable heat stabilizer, so that those causes of aging like oxygen, presence of ozone, um, irradiation with the UV from the sunlight, or due to heat, that kind of degradation can be some extent reduced at least. The term aging of polymers is usually associated with long-term change of polymer properties under the condition of weathering and may involve in any of the above process. I have just already discussed the matter. And these are the pictures you will find that what kind of aging process is going on in an environment. If you keep the plastic spoon, that will be gradually turned into this page, and it is very common example. If you keep a motor tire for a long time in the environment, after few months you will find this kind of degradation will be visible. These are very common. This is pipe, plastic pipe. If it is exposed to the atmosphere for a long time, this kind of holes will be generated. So antioxidants it prevents, means it will extend the time for degradation. Means for a long time, it can prevent the degradation process. So it will slow down the degradation process. But mechanism is different. Some type of antioxidants, chain breaking antioxidants, preventive antioxidants. Chain breaking on antioxidant means intervene in the propagation cycle reaction, because we know the polymerization process will have the propagation stage. So once the polymerization starts, it will be further propagated very easily. Similarly, the degradation process you may consider this is the anti-polymerization process. There is a role of free radical. So once the free radical is generated in the polymeric body, so the anti-polymerization process will be faster and faster. So the degradation process will be executed more. So the chain breaking antioxidants actually its role is once the free radical is generated, so that will be scavenged by the material, by the antioxidant, that will be separated, that will be consumed, so that the further propagation of the depolymerization process, that will be slows down. And preventive antioxidant, this is actually prevent the formation of it. It also the use of preventive antioxidants, they prevent the formation of free radical. So the process of degradation that will not be started once the radical is not generated in the site. They are functioning in different ways. Antioxidants prevent or slow down the degradation of material caused by ozone. This is actually ozonolysis. Ozonolysis is a process of degradation. So the antioxidants, they will function in this way so that they prevents the degradation due to ozonolysis. Unsaturated polymer, because ozone is very susceptible to the unsaturated polymers. So unsaturated polymers, if it come in contact with ozone, then degradation or ozonolysis will start, and cracking of rubber tires and hoses is mainly due to the ozonolysis, or due to the degradation in presence of ozone. Yes, this is the picture. Thermal degradation, similarly, thermal degradation is very prominent in few polymeric product like polyvinyl chloride. If we look into the structure of polyvinyl chloride, that it gives due to thermal degradation, a conjugated diene system is produced by eliminating HCl. So, and more importantly and most interesting is that once the one molecule of HCl is produced in the system, the process of degradation will be faster because the produced HCl is acting as catalyst for further degradation. And not only that, after degradation of PVC, a conjugated diene structure like this is most stable structure, conjugated diene system. So most stable structure. So obviously process will have its own tendency to stabilize in a stabilized form, and that's why PVC is very susceptible to thermal degradation. Photo stabilizers, photo means mainly the degradation due to UV radiation in the sunlight. When the polymeric product is exposed in the sunlight, due to presence of UV ray, the degradation process been started. And photo stabilizers are those stabilizers in presence of those material, they absorb the UV radiation on its own surface so that it prevents the polymeric product from the UV radiation. Colorants, colorants means the polymeric product, finally the final product which is produced by using different polymeric material. They are also produced in different colors. So the coloring matters or coloring ingredients are to be incorporated during compounding process before giving the final shape of product. And colorants, if we look into the colorants material, either they are organic dyes or pigment or inorganic pigment. They are different characteristics. So depending on the characteristics of the polymeric material, you have to select a particular pigments or dyes. Dyes, the molecule in a dye actually dissolve and become part of the molecule structure of the polymer. And pigments are filler material that do not dissolve. Pigments, actually dyes are dissolved in the polymeric uh, material, in the polymeric surface or in the polymeric body. But pigments, they will just cover the surface. They will just cover the surface in different color, but they will have remain in separate phase. Blowing agent is another one ingredient, important ingredient that blowing agent means uh, for making the foams. These blowing agents are utilized so that they will create some air pockets inside the matrix, polymeric matrix. So the floppy kind of material, polymeric material, is produced by using the blowing agent. Foams, one of the common example, cushions in automobile furniture, packaging and thermal insulation. This kind of blowing agents are used. Liquid carbon dioxide can be used sometimes. Means blowing agent are like a kind of material that after under when it is exposed under high temperature, it breaks into the gases. Curing agent is very prominent in case of natural rubber. We have seen that curing natural rubber, it is obtained from the nature, but its tensile property is very less. Raw rubber, raw natural rubber. So, but if it is cured in presence of sulfur or in presence of some curing agent, suitable curing agent, so that by cross-linking process, its mechanical strength, tensile property, uh, elasticity, that will be further increased. And vulcanization of styrene butadiene rubber curing agent is used. Captex, Centocure, curing of polyester, That is benzoyl peroxide, the initiator. Actually, their role is for making the bond in between two molecules. Natural rubber, sulfur is most common cross-linker or curing agent for natural rubber. So these are the main ingredients. These are the called main polymer compounding ingredients. So in the next lecture, we will discuss about the techniques, processing techniques. Thank you.